Okay, so getting started on chapter 11 here with 11.1. So this chapter is called differential equations, which we've been dealing with differential equations. So any equation with a derivative in it, we are just going to dive a little bit deeper, just really the surface level of what you'd see in the actual class differential equation. So number one says y equals x cubed, a solution to this equation. So we're going to take this derivative. So the derivative of x cubed would be 3x squared. So we're going to replace y prime with 3x squared. And then we're going to replace y with what y is equal to, which is x cubed. So we're just trying to get this entire equation in terms of one variable. So that variable is x in this case, usually the independent variable. If we were to multiply these, we get 3x cubed minus 3x cubed equals 0. So that is a solution. Number two says, show that this right here is a solution to this equation. So the first thing I'm going to do is take the derivative. That's a number, so it goes away. The derivative of this would be k times c e to the kt. So the derivative of, if you think of this as like 5e to the 2t, I get 5e to the 2t, and then I multiply by the derivative of the power, which in this case is k, so I get kc e to the kt. So I'm going to replace this with kc e to the kt. And I replace the right side. I'm going to go in and replace the y with what it's equal to, which is this one here. So a plus c e to the kt minus a. So I'm just trying to get everything in terms of t in this case. So if I were to simplify in here, this a would cancel with this a, and you will see then that if I put this here, I get k e to the ct is equal to k e to the ct. So that is a solution. Here it says, show that for any constant p of 0, the function p equals p of 0 e to the t satisfies the differential equation dp dt equals p. So this is saying, essentially, if you take the derivative, you get the thing back. So if we have some number, p sub 0 e to the t, think of this as a 2 or a 3 or a 5. The derivative of this is just going to be p sub 0 e to the t. And another name for that is just p. So when we take the derivative, we get back the original function. This is an idea we're going to see quite a bit. Not exactly the original function, but values of it. So number 4 says, find the values of k for which y equals x squared plus k is the solution to this equation. So first thing, if I were to take the derivative of this, I would get 2x. So I'm going to go down here and I'm going to replace y with the x squared plus k. And I'm going to replace y prime with 2x. And that's equal to 10. So I get 2x squared plus 2k minus 2x squared equals 10. The 2x squareds go away, 2k equals 10, so k would have to equal 5. If I go up here to number 5, it says, for what values of k, if any, does this equation satisfy that? So I'm going to take the derivative. So the derivative of this, the 5 would go away, and I would get k 3 e to the kx. On the right, I'm going to get 10 minus 2 times y is 5 plus 3 e to the kx. So I get k times 3 e to the kx equals 10 minus 10 minus 6 e to the kx. So these go away, and I've got this and this. And that would mean the only way this side could equal this side is if k is equal to negative 2. Number 6 says, show that sine of 2t satisfies this equation here. So I'm going to need to take the second derivative. So I have y prime equals 2 cosine of 2t. And I got y double prime equals negative 4 sine of 2t. So derivative of sine is cosine tagged with a chain rule. Derivative of cosine is negative sine tagged with a chain rule multiplied by that 2. So I'm going to put this here in for the second derivative. So I've got negative 4 sine of 2t plus 4 times y. Well, y is sine of 2t equals 0. So this plus this equals 0. So check. And then the last one, it says, for what values of w, find the values of w for which y equals cosine of wt satisfies this equation. So if I go down here and I take the derivative, let's give a little more space. If I take the derivative, I get negative w sine of wt. So again, derivative of cosine is negative sine, derivative of wt is w. Then if I go y double prime, The derivative of sine of WT is going to be cosine. I'm going to get another W, so I'm going to get negative W squared cosine of 2t. So I'm going to go replace into this equation. So I'm going to get negative W squared cosine of 2t plus 9 cosine of WT. Or sorry, I don't know why I had a 2 here. This was never a 2, always a W in here. Okay, and if I want this to equal 0, then pretty straightforward. This W squared has to equal 9. So that means W could equal plus or minus 3. Okay, there's 11.1 for you. I'll be back with the slope field packet here in a minute.